grateful for everyone to come out on a beautiful evening to hear some perspectives on coastal erosion at Kalaloch. And I've known Ian now for, I've been at the park for 18 years. I think I've known Ian for that long. We have kids that are about the same ages and do some of the same activities and things. And Ian's also been a supporter of the national park in many different ways over the years. I'll let him talk about it, but some of the things that I've seen Ian do, I've seen him radio tag rocks in the Ella and talk about it here in a Perspectives program previously. I've been out at the Three Rivers Fire Station out by Mora in La Push, as he's been the registration person for the coastal cleanup. So I've had the privilege of doing that with him. He's been a great speaker for park employees and training. And so he's a great supporter of the parks, and we're really fortunate to have him in the community and have him here tonight. And so I'd like to introduce Ian Miller.
Okay, am I hearable if I talk like this? Is that okay? So I don't have to hold this? Okay. If I get too quiet, just wave or shout or something. Thank you for those of you that did the active poll. I wanted to get a sense to see where people were at. I know we have some more times that I can remember people in the audience. I can do it. Okay, but that's okay. I know you're here. I just wanted to acknowledge, so this is indeed focused on coastal bluff erosion at Kalaloch. Many of you in the room know this site far better than I do, so I hope they do a good job. But my name is Ian Miller. I work for Washington Sea Grant. It's a University of Washington-based program, but I am based out here on the peninsula in Port Angeles. My office is at Peninsula College. And Sea Grant is like a marine extension program. So we are sort of there to try to connect science to communities and entities on Washington's coast that can use it to hopefully help us manage the coastline of this, this amazing coastline that we are fortunate to live by. I focus on hazards. My background is in sciences. I have a PhD in coastal oceanography and geomorphology. Things like erosion are exciting to me, and is one of the reasons why I decided to focus out here at Kalaloch. So my goal for tonight is just to try to tell a story about sort of erosion at Kalaloch with a focus on sort of modern erosion. I'm going to touch on a bit of history of the site. That was the part that I knew least about, so it was kind of exciting to try to dig into it. Hopefully you'll find that interesting. And then a bit on the geology, and then focus on some of the data that I collect, monitoring out at Kalaloch, and then also sort of the management that the Olympic National Park is currently doing associated with erosion at Kalaloch. But I'm going to start with a bunch of acknowledgements. First, I have a lot of people that I wanted to recognize, but first, you may be aware, maybe not, that it is National Library Workers' Day, and we are fortunate to be doing this in a library. We are fortunate to have this library. So thank you to the library for hosting. And thank you to the library workers for the work they do. We do really have an amazing library. This is my long list of names, just to get them up on the screen. There's a variety of people that made giant contributions to what I'm going to tell you. And Stephen Bradkin, who's in the audience, coastal ecologist from the Olympic National Park. You may have seen Steve's presentation last month, I believe. Roger Hoffman, also from Olympic National Park. Is Roger here? Okay. He's online. Great. So Roger's online. I had a chance to talk to Amy Neal, who's the manager from Delaware North, who is the current concession holder at Kalaloch, about impacts to their business. Paul Gleason happens to be my neighbor, retired from Olympic National Park, just a wealth of knowledge. I always go to Paul over the fence when I have questions about really anything associated with history in the park. I talked to Jack Galloway and Ben Hertel, both of whom have a long history working at Kalaloch. Jill Silver, who grew up going to Kalaloch as a kid. Linda Heusser, who you'll hear me talk about a bit later, at Columbia University in her mid-90s, still an active researcher, got her career start at Kalaloch. And then had the good fortune to go find some information about Kalaloch at the North Olympic History Center. And then also my work at Kalaloch has been funded in the past by the North Pacific Coast MRC, and then an NSF program called the Cascadia Coast Hub. And then continuing the acknowledgements, I also made use of 2 written resources that I just wanted to give a shout out to because they were both fantastic. And I've also stolen quite a bit from them without credit throughout the talk. So I want to give the credit now and call that good. The first is this little book, Kalaloch Lodge by David Emick, who is based down in Grace Harbor. This is held by the library, so you can check it out. It was published last year, I think. And it's just a really cool little collection of stories and photos going all the way back to the founding of Castile, the town of Castile, around the mouth of the Kalaloch River. And David has a particularly interesting relationship to Kalaloch. That photograph is his grandfather, Edward Emick, who was an engineer who completed the loop highway, which the completion of that loop highway was a major sort of feature in the history of Kalaloch. So kind of a cool connection for David Emick to the site. And then the other is this 1983 historic resource study, which Paul Gleason gave me, which I also found to be extraordinarily interesting and fascinating. I don't know if this is available online. I certainly hope it is. But both of these pieces of writing, I stole a lot of photos from and stuff like that. Again, and the photos in David Emick's book are mostly coming from the Polson Museum, which is a historical museum down in Grace Harbor, and then the Becker family. Okay, so geographic orientation. At least a few of you, it sounds like, haven't yet had the chance to visit Kalaloch. I hope you do. Kalaloch is down on the very southern end of the coast strip in Olympic National Park, circled in red there on this map of the national park. And, you know, it is indeed a very special place. This is a aerial view looking from above the ocean towards Kalaloch, sort of identifying some of the key features that I may mention. Many of you have probably been to these places, but the lodge is a prominent feature right along the highway. Those cabins that stretch along the shoreline, those are going to be a main feature of sort of the erosion story. There's a beach access point identified there. Kalaloch is a heavily used beach area, lots of access, so those access points are key. It's got this beautiful broad sandy beach that you know, is just a quite enjoyable place to be. Kalaloch Creek cuts through right through the center of this photograph. And then the Olympic National Park campground is off the screen this way, but a fairly large and heavily used national park campground at the site. So, you know, again, in prep for this talk, I wanted to do this kind of historic deep dive. And for me, the primary question was, what is the history of erosion at this site? That's kind of what I was looking for in trying to find some of the historical documentation I could find. But I also just found it fascinating. So I wanted to review it very quickly. I should note that this is all sort of colonial history. I don't attempt to or know anything about the tribal history, although I'm sure that it was significant at this site. But the sort of colonial history starts in the 1890s with the settlement of sort of the mouth of Kalaloch Creek into a small village settlement that got the name Castile. And it was initially settled by Tom Lawler and J.J. Banta, who, as far as I can tell, wanted to establish a cannery at the site. They both had cannery experience from down in the Grace Harbor area. And they did, in fact, establish a cannery at the site, canning, it sounds like, primarily razor clams. And then a sort of a small group of structures grew up around that. The photographs that I'm showing you on the screen here are, as far as I can tell, on the south side of the creek in places that I cannot identify anymore. So I don't have a great sense for exactly where these sat. They were destroyed in 1921 windstorm. The other sort of thing that's alluded to for Kalaloch in terms of its economic development was gold mining, apparently an activity here at this time as well. But in 1921, it sounds like most of Castile was destroyed by the 1921 windstorm. and was kind of on a downturn for a little bit, a couple of years, until in 1925, it was purchased by the Becker family. Charles and Mary Becker and their children acquired 40 acres, mostly on the south side of the creek. Lived in some of the structures that were left over from Castile. And Charles was very interested in establishing a hunting and fishing resort at Kalaloch, and so built a store. That store is the same structure, same location as the store that is there currently. And then also quickly started to construct cabins. The photo in the corner is the first 2 cabins that were constructed at Kalaloch. Apparently mostly of lumber that was milled that had been part of Castile, that again had been destroyed in the windstorm and was scattered around, gathered up, and was used to build those first couple of cabins. And it's worth noting that at this time, 1925, the site was only accessible by boat or by foot from the south, from Grays Harbor. So a hard place to get to. So a few other major milestones at Kalaloch that are relevant to our story here. The big one, 1931, the Loop Highway was completed. Kalaloch was suddenly accessible by car and sort of boomed as a consequence. In the early 40s, it was taken over for military purposes and became the headquarters, one of the headquarters of the Coast Patrol. And from there, something like 150 personnel would fan out and patrol the shoreline of the Olympic coast. 1953, the coastal strip was established. And then in 1955, the current Kalaloch Lodge was built. There was a lodge there initially associated with what was called Becker's Ocean Resort that was burned down by the military personnel that were living there at the time. It was replaced by a tar paper shack. So then the current Kalaloch Lodge was built afterwards. 1963, the site finally got power. I think that was the thing that was the biggest surprise to me. And then in 1978, Olympic National Park purchased what was called Becker's Resort, changed the name to Kalaloch. And then in 1980s, most of the current bluff cabins, the cabins that sit along the bluff edge, were built, as far as I can tell. Would love, I know there's some people that have been there a long time, so that's not the case, would love to know. But anyway, so obviously this site didn't become, or at least still is not, the fishing and hunting resort that Charles Becker sort of envisioned, but it is certainly one of the premier sort of spots on the coast. One of the, it is, I believe, the only of the sort of remaining resorts that were along the coast for a long time. And obviously a critical spot for beach access for a huge number of users. Kalaloch Lodge generating something like $7 million in annual revenue, a major venture. Kalaloch Campground, major national park campground. And then something that Charles Becker and Mary Becker probably couldn't even conceive of, a famous tree that, as far as I can tell, draws about 90% of the visitors to Kalaloch these days, based on the questions that I get when I'm walking around there. Where is the tree of life? I hear it numerous times on any given visit to Kalaloch, so pretty astonishing. Okay, but what Kalaloch also has in spades, and the reason that I am here, is these bluffs. And so I've tried to sort of outline those in white, what I refer to as the Kalaloch bluffs, stretching along the shoreline on the lodge side, and then off the screen, bluffs underneath the national park campground as well. And that's what I'm going to turn my attention to now. And just starting with a bit of definition. What is a coastal bluff? What do I mean when I use that term? So there's a variety of definitions of exactly what a coastal bluff is. But an example, very simple, it's an escarpment or a steep face resulting from erosion of sediments that has a vertical relief of 10 feet or more. That number changes a bit in different definitions and is located in the coastal zone. So that's a perfect picture of a bluff. It is worth noting that it is not a cliff, right? So it's not composed of rock, it's composed of a pile of dirt. And that is a key part of the definition of a bluff. And another key part of that definition that's important to our story today is that coastal bluffs are, by definition, erosional features. They are formed from erosion and they persist because of erosion. And so erosion is part and parcel of the story of coastal bluffs. And erosion, of course, is this process by which the ocean steals land. So transfers land into the ocean in ways that can be problematic for people, especially if we develop those areas. And then I also just wanted to stop here because I'm starting to get into this erosion business. I found this quote in the Seattle Times. I thought it was awesome. Erosion is a natural normal, and unless you have a special affinity for geology, pretty boring process. So I just want to give you your chance to like leave if you're like, okay, I thought I was signing up for like living cool things. It's all about erosion from here on out. Okay, so around us here on the Olympic Peninsula, I'm going to sort of spend a little time talking about, how do we end up with bluffs? And around us, the formation of coastal bluffs almost always has something to do with glaciers. And it's no different at Kalaloch, but unlike here in the Strait and in Puget Sound, where a lot of the coastal bluffs are composed of material that sat underneath large continental glaciers, out at Kalaloch, which was never under a continental glacier, it's actually composed of material that is referred to primarily as outwash. And so glacial outwash this is a photograph from Alaska, is basically the material that rapidly accumulates at the toe of the glacier as it retreats, just associated with the massive sort of movement of water and all of that sort of eroded material underneath the glacier out in front of it. And it accumulates in these kind of plains. And this is outwash. And the evidence for this at Kalaloch actually comes from the bluff itself. But before we get there, this map is a little bit hard to read. This dates back to a paper from 1974, but attempts to show the boundaries of glaciers in Olympic National Park. And in particular, I've marked Kalaloch with a red arrow there, so hopefully you can pick it out. And then these black dash lines are, again, these estimated glacier boundaries. And the two that I want to draw your attention to are this boundary line right here, which is for the Queets Glacier. This is, by the way, long in the past. And then the Hoh Glacier to the north of Kalaloch, which has kind of two boundary lines drawn there. So again, these are estimates of, prehistorical positions of those glaciers. But you'll note Kalaloch was never, based on this map, was never, essentially under a glacier. But we can turn to the bluffs themselves to see evidence of this process. So, I'm sorry, Chris. So there's a couple people, but notably Glenn Thackeray, who have done work on sort of trying to map and understand the geology of the coast. Glenn Thackeray did a dissertation focused on sort of mapping sediment layers across the entirety of the coast. And what you're looking at here is one of the figures from Glenn's dissertation from 1996. And this is a stratigraphic section. So basically what you're doing is you're sort of imagining you're out on the water looking at the coast and you're able to see sort of the sediment layers. And you can see there's maybe out of 5 or 6 units that Glenn has mapped there between Browns Point, which is north of Kalaloch on the beach. And then here you can see Kalaloch Creek and a little bit to the south of it. And what I've tried to do here is take a photograph from Kalaloch and sort of map those units onto the photograph. And at Kalaloch, we really see 3 primary units. We see what Glenn Thackeray has labeled Lyman Rapids Outwash, which is basically outwash material from an advance of the Queets Glacier. And Glenn also, in addition to mapping, did a bunch of work to try to date these layers. When were they laid down? And that Queets Glacier advance outwash dates to over 70,000 years ago. So, imagine this kind of massive glacier pouring out of the Queets Valley, which is now obviously far retreated. And then above that is a layer that's associated with the last glacial period, 20 to 40,000 years ago. And that is composed primarily of peats, fine sediment. So this is kind of from a time period when this part of the Olympic Peninsula was probably tundra-like. And basically you had sort of vegetation that was growing and sort of rotting year after year after year to sort of develop those peat layers that you see there. And then above it is a more recent layer of loess, which is this kind of wind-blown material that accumulates slowly, especially in recently deglaciated areas. That's at the very top of the Kalaloch bluffs there. And the bluffs at Kalaloch, as I sort of alluded to at the beginning, are also important for other reasons. So some of the earliest groundbreaking work in what is called palynology, or understanding past climates through the study of pollen preserved in sediments, happened. This is Linda Heusser, who I mentioned in the acknowledgements. I actually reached out to Linda in advance of this talk. Again, she's in her mid-90s now, but still is an active researcher at Columbia, to ask if she had any cool photos. She said, I'm sure I do, but I have no idea where they are. So I didn't get any, but really, really cool. Linda's story is a really cool one. Anyway, she did a lot of this very early work on understanding past climates on the Olympic Peninsula, using the pollen record primarily from those deposits in places like Kalaloch to sort of understand what the vegetation was like. And then from that, you can infer what the climate is like. So these squiggly lines on this plot over here, I don't want you to pay attention to them, only to note that that's the product of years of this painstaking work by Linda to put together this climate history for Kalaloch, and that comes out of those eroding bluffs. And then coastal bluff erosion also is viewed as a habitat forming process, right? Coastal bluff erosion has this other benefit, or at least in some places it's assumed to have this benefit. Anyone recognize where this photo is from? This is Dungeness Spit, right? So in the Salish Sea in particular, the erosion of bluffs is thought to be a habitat forming process. And basically you can see the bluffs in the foreground. And the idea is as they erode, they contribute sediment to the shoreline, which then forms these very unique and high value habitat features on the shoreline. So coastal bluffs have sort of a number of interesting kind of benefits, and both scientifically and from a habitat standpoint. So why do they erode though? What are the processes that drive bluff erosion? So this is kind of the standard textbook answer to that question. And basically in this particular figure, this is one you might see in a coastal geology textbook. You've got sort of a coastal bluff and then interaction with the water, or sort of typically associated with storm-driven processes, high tides, waves, sea level rise can exacerbate this process, sort of erode out a sort of notch at the base of the bluff. The bluff eventually becomes unstable and fails in some way, shape, or form. And then you have erosion of that failure material, and eventually it returns to a vertical state that allows for that sort of that undermining process to start over. This is kind of a classic kind of model. And at Kalaloch, we do see evidence for this model playing out. You've probably seen this if you've been there. This photo is from Saturday, but you can see it almost any time you go there, where you can see the sort of erosion divots in the base of the bluff. This is under the cabins on the south side of the creek. And then also, these failures, this is also from Saturday, associated with, the material above those carved out parts of the bluff failing. So we see that process playing out at Kalaloch, but as you might imagine, bluffs are quite complicated, and the reasons that they may fail go well beyond those sort of obvious interactions with the ocean. They are complex from a sedimentological standpoint in terms of being composed of a bunch of different kinds of sediments with different hardnesses, different abilities to hold together. Water flows through those layers, sometimes in complex ways. That can freeze and thaw. This is a great photograph that Steve took on what was obviously a very cold day on the beach. This freezing and thawing is thought to weaken those layers and bluffs and potentially play a role in erosion. The other thing that's not listed here, but may play a role in that sort of diagram I showed you, the alluvium, this kind of material that's gathered in front of the bluff, can act to protect the base of the bluff. But at Kalaloch, the other prominent feature is large wood. and exactly what role that plays in bluff erosion. It might actually protect the base of the bluffs. It could also act as a battering ram during storms. So what direction that plays isn't at all clear. But the point is that it's often difficult to sort of identify a single cause of bluff erosion or understand exactly what process is at play when it occurs. So as a consequence, what we typically focus on are just measuring rates. How quickly is it occurring? And trying to understand, past conditions basically. And it won't come as a surprise. I sort of started out by saying, hey, bluff erosion is, coastal bluffs are erosive features. They are there because of erosion, and erosion is not new at Kalaloch. So there's really 2 points of evidence that I want to point to for that. One is this report published in 2002, roughly 20 some years ago now, a shoreline change study of Kalaloch Lodge to support decision-making that was happening in the park. At the time, really focused on the lodge, sort of the bluffs underlying the lodge, although this report did analyze erosion along the coastal bluffs as well, more along the shoreline. What they did to do this was basically use aerial photographs of the site from between 1974 and 1997 to estimate average rates of erosion. You can see, this is actually sort of, it's hard to see, but this is a map of the site. You can see the cabins there, the creeks up here, and those colored lines are basically bluff edges that they hand drew. Again, to try to understand what the rate of erosion was at Kalaloch, and what this group found, again, this is the Coastal Monitoring and Analysis Program from the Department of Ecology, is they found average erosion rates of between 3 inches and 1 foot per year over that 1974 to 1997 time period. So 3 inches to a foot was kind of the number that they came up with for an average rate of erosion at Kalaloch. So the history of erosion goes back further on this site, certainly though, won't come as a surprise, I think, to any of you. This was a quote that is in David Emick's book that definitely caught my eye. The beautiful lawn between the cabins and beach gradually eroded to the point where if the cabins had not been replaced in the mid-1950s by even more modern cabins, they would have fallen onto the beach. So clearly, bluff erosion has been a long-standing issue of one kind or another at Kalaloch. So back when I started with Washington Sea Grant, roughly in 2011, I sort of quickly started to look for places to implement a shoreline survey methodology. These were methods that I developed to try to understand how the Elwha dams would influence the shoreline, here on the Strait of Juan de Fuca. But the methods can be applied almost anywhere. And Kalaloch drew my interest for the reasons kind of that have been described. It's an erosive place and it's a high value place. And so it struck me that having a data set from a place like Kalaloch would be potentially useful. And so the process that I use is to establish these cross-shore transects along the shoreline. That's what those red lines represent on this map. And hopefully you can make out Kalaloch Creek right here in the middle. So the lodge down here, campground up there. And then basically along those transects, usually me, can walk a device that looks like the one right there, that surveyor is holding. And you sort of walk it up the beach. And as you go, it's collecting high accuracy locations and elevations approximately every second. So by the time you finish walking up that transect, you've collected sort of a pretty dense data series along that transect, which I can then take and draw what is called a profile from. And so this is intended to show you sort of all those dots are the individual points collected by that device. I can draw a line through them, and I can translate those positions into distance along that transect. And then I've got an elevation on the side that's in meters relative to mean lower low water. And what I'm doing is I'm getting a sort of sideways view of the shoreline on that particular day and time. Pretty boring as it stands, but what I can do is I can come back and do that again, and then again and again. and start to build up a record of what the shoreline is doing on that transect over ideally long timeframes. So out at Kalaloch, I've been doing this for roughly 10 years now. And so what you see on the top there is an example from, this is from the transect that cuts through the bluff just to the side of the sort of gazebo at the Kalaloch access point. If you can visualize where that is, that map is completely unuseful at the bottom because you probably can't see it. But in this particular case, there's all these profiles stacked on top of each other. The darker colors are some of the original data from 2013. The sort of the more reddish colors are more recent surveys from 2024. And, you know, hopefully your eye catches the difference there, which is the erosion. This happens to be the most rapidly eroding section of bluff that I survey. And then what I can also do with that is I can sort of use that to estimate a rate of change. So I can sort of use the distances of each of those profiles. I've got a time associated with those, and I can create something that looks like this, which is just sort of a time series of the position of the bluff, in this case from 2013 to 2024, and it's a line that's got a rate. So I can use that to estimate a rate of change. So to try to make that easier on your eye, this is the results summarized for how the bluff face has changed between 2011 to 2023, again, based on this survey data that I collect. Kalaloch Creek is right here, the lodge here, campground up here. And most of those transects up in the campground area and then south of the lodge are in this 0 to 6 inches per year range in general. So about what the Department of Ecology found back in 2002 when they published their report. And that's kind of nice to see some agreement between those two methods, and also gives us a sense for what I think of as like a background rate. Again, bluffs always erode, you expect to see something. And so this gives us a sense for what we think might be sort of unexpected background rate. It's also, to me, astonishing to see those bluffs hold up to the ocean and only give up a few inches a year, right? That's pretty amazing. If you've been out there in the winter during a storm, this is astonishing to me. I don't know how it works, but if we zoom into the lodge, things get a little different. So zooming into the lodge here, and here we see rates that are considerably faster over that time period, 2011 to 2023. That was the set of profiles I showed you earlier, rates of 3.5 feet per year. So significantly faster than the Department of Ecology found. 1 foot a year just to the south of the gazebo. But then interestingly enough, a declining rate as you move to the south, right? So kind of an interesting thing to see in these data. And that erosion, of course, has consequences pretty much anywhere, certainly in places like Kalaloch, where there's a lot of use, there's a lot of fixed development on the shoreline, so it causes mayhem, it causes damage. These are a couple photos from just a few days ago, impacts to trails, impacts to access, and other site features. So somewhat as a consequence of that sort of increasing sort of, I guess, rate of impact associated with these kinds of features at the site, starting in 2023, Olympic National Park really started to focus on erosion at Kalaloch, both from the standpoint of trying to figure out how to maintain access at the site, as well as how to maintain safety, right? So obviously those bluff cabins that are arrayed along the bluff, people stay in those, they rent them. At some point that erosion presents a safety issue. So the park very quickly established a removal program for those bluffs. This is a photograph. This is also just from Saturday. So this is a tagged cabin. And what they did is they established 5-meter buffers around each of these cabins. And basically, when the bluff edge comes within 5 meters, sort of advances beyond that buffer, that cabin is removed from Kalaloch Lodge's rental rolls, or however they talk about it in the hospitality industry. And then that cabin is then also slated for removal. So associated with that was also some higher frequency monitoring that was put in place, also around the same time. I think that this map, which represents this kind of higher frequency monitoring data, also shows a few other things of interest. So first of all, those two kind of the red and green line, if you can see those, they're hard to see right here. Those represent these bluff edge surveys. That's basically me or Steve walking along the edge of that bluff very carefully and basically surveying its edge. And the green line, the red line was one of the first ones that we collected. That's from October of 2024. And the red line, let me try that again. The red line is from October 2024, and the green line is from Saturday, from April 5th, a couple days ago. And I think the thing that this does is it obviously reinforces that there's, rapid erosion occurring at these bluffs, especially up on the creek side, but also to a degree on the ocean side as well. If you can see those little gaps between those lines, I know they're hard to see. Maybe you can make them out in a place like up here where you see that separation. Even though that separation looks small on the map, that's close to 5 meters. That's close to 15 feet or so of change over that time period. So that kind of accelerated erosion, I think, is represented in these data as well, which are collected more frequently. The other thing you can see on this map is the cabins in pink, and the crosshatched cabins, there are 7 total on this map, are ones that are no longer being rented, either because they are removed, that's the case for the bottom 5, or because they're now closed to rental, because they've come within that 5-meter buffer. That's those 2 up here. And you also, if you look closely at this map, there's a few other interesting things. You can see this cabin right here, which was removed last year. The bluff has now eroded very much into where that cabin once stood. And then you'll also notice that like cabin 5 and cabin 4, for example, are pretty close to that 5-meter boundary, right? So it is likely that those cabins are probably soon going to be lost as well for rental at Kalaloch. And then around that same time, we also installed 5 Chronolog stations at Kalaloch. And I'm going to tell you this because I'm going to show you some photos from them, but also because I encourage you to use them when you go out to Kalaloch. And what Chronologs are, they look like this. It's a little post with a cradle on it and a little sign. And the sign encourages you to put your phone in that cradle, snap a photograph, and then there's an email address that you email it to. There are 5 of these in total at Kalaloch. There's 3 on the lodge side, 2 on the campground side. And these were put in place late in 2023, just as another kind of high frequency monitoring tool that gives you a sort of visual perspective on what's happening on the shoreline. And they also have this nice feature where once you email that photo in, you get an email back with the time lapse from the site, as well as information about the erosion occurring at the site. So they have this nice sort of interpretive component to them. There's a website where you can go look at these photos. But just in case you haven't been out there and had a chance to see what that kind of cabin removal and erosion process looks like, a couple photos from one of those Chronolog stations. This is the one that's just to the south of the sort of gazebo trail down to the beach. This one's now behind yellow tape, but be careful. You can, well, I shouldn't say that. Anyway, this is February 27, 2024. And then you can hopefully make out, this is in the process of cabin being removed from this site right here in March of 2024. So just a few weeks after that initial photo was taken. And then this is the most recent, or not one of the more recent photos from the site. This is a couple weeks ago, in which hopefully you can very clearly see the loss of, fairly substantial 2 chunks of bluff in that sort of relatively short time period. Okay, so what's ultimately driving, this apparent acceleration? So that pattern of decreasing erosion from the creek sort of points a finger, right? The creek seems to definitely have something to do with it. You'll notice that there was no creek on that conceptual model of bluff erosion that I showed you. So what's going on here? Well, we don't really know exactly, but I think that just a few weeks ago, Steve Fracken actually noticed an interesting pattern in looking at some of the historical photos of the site that I think is kind of compelling and something that we might be able to follow up on. So what I've got here is an aerial image. This is from Google Earth from June of 2009. And what you can see here in terms of the position of the creek is that the creek is deflected far to the north certainly from the bluffs. And in fact, here you can make out those bluffs are actually vegetated, clearly stable. There's a lot of wood accumulated in front of them. This is what the site looked like when I started working out there in 2013 in terms of those bluffs right underneath the cabins. And then by February of 2024, we can kind of see that the pattern's reversed. The creek's been shifted to the south. There's a huge accumulation of wood and sediment to the north of it. And so, there seems to be some pattern associated with deposition of sediment at the mouth of the creek that may be driving it to the south. I've seen this in other small creek mouths, driving erosion in other places on the Olympic Peninsula, very localized erosion around these small creeks. Generally not a problem if they're not developed, but if those adjacent shorelines are developed, it can be quite problematic and very localized. So why exactly this is happening, again, isn't totally clear. There's all sorts of potential hypotheses associated with how sediment moves on the shoreline, possibly to do with flow from the creek. Lots of hand waving that we could do, but something that we might have a chance to follow up on. But I think most importantly, one of the factors determining sort of how Kalaloch is managed, how decisions are made at Kalaloch, are also informed by the fact that Kalaloch as a coastal area faces stresses in the future that go beyond sort of these potential drivers of erosion currently. So what I'm showing you on the screen is some work done by Meredith Luong, who's a graduate student at Oregon State University, just finished her PhD. And what Meredith did was linked sea level rise projections to basically storm model information from the Pacific. Things like tides and waves that interact to create storm damage, basically, during extreme events on the coast. And kind of did all this fancy math and modeling, but ultimately broke it down into three what I think are pretty interesting and useful metrics for thinking about what actually matters to us on the shoreline. She did this for the entire coast of the Pacific Northwest. These results actually are for Kalaloch. And there's kind of three symbols you'll see on here. Ignore the blue one because it's not relevant to Kalaloch. It's called overtopping. That's kind of like when storm-driven waves go up and over a berm to flood the backshore. At bluffs, that doesn't happen. The two that are relevant, though, are the yellow, which is this unsafe beach metric. And basically what she was trying to measure is how do the number of hours that a person can safely walk on the beach change as sea level rises. And she expressed that as a percent change in the number of hours. That's the scale on the left, if you can make out those tiny little numbers. And then the collision one is probably the most important one relative to erosion at Kalaloch. Collision is this idea of how often is the ocean actually pounding on the base of the bluffs? How often is the ocean colliding with the base and sort of carving out those notches and facilitating erosion? And you can see the trend right at Kalaloch. Again, when we think about sites like this in the context of climate change and sea level rise in particular, we expect that the amount of time that the ocean is going to be pounding on those bluffs and presumably eroding them and accelerating that erosion will be increasing in the coming decades. So information like this plays a role, presumably, in the decisions that we make at sites like Kalaloch. Okay, so that's everything. I have a few key points here, stuff that I've talked about before. I'd love to get your impressions, or see if you have any questions. And thank you so much for taking your time tonight.
Okay, thank you very much. We have a couple minutes for questions. So if you are in the audience in person, you can raise your hand and Audra will bring you the microphone. And if you are joining us online, you can put your question in the chat and I will read it out as time permits. Would anybody like to get us started? I'm in the front.
Based on the rates of erosion, but how long will it be before the lodge and the highway are in danger?
That's a great question. So if the erosion is localized where it's currently localized, a long time. Now, there was a period of historic, a few decades ago, at which it was really the bluff underneath the lodge that was the main focus of concern. And so what that tells us is that presumably those kind of hot spots, even in a site as small as Kalaloch, might move around. So I think in that period of time in the kind of late 90s and early 2000s, when the lodge was threatened, there was kind of efforts to figure out management options there. My understanding is that, the hotspot moved presumably somewhere else. And so will that happen here again? Remains to be seen. Hopefully it does, although where it moves to may cause problems as well.
Another question?
Yeah, I got here a little late and I'm really sorry
That's quite all right.
because I just did. But now does, any of these small tremors that we have out in the Pacific have anything to do with erosion? Thank you.
It doesn't appear to be the case. I think that, one of the things that I didn't really get into is, the other point of evidence that we don't have a broader regional erosion force that is changing, if that makes sense, is the fact that the acceleration is very localized near the creek, right? If we had something broader occurring regionally, say it was associated with earthquake swarms, or maybe it was associated with sea level rise, we would expect to see an acceleration in erosion over a broader area, right? We don't see that here. When we go north of the creek, when we go south of the lodge, we tend to see background rates that are very much like what were measured in the late 90s. And so that's good. And so it just doesn't, it sort of helps us to be able to exclude some of these, what presumably would cause broader regional issues. It is worth noting, this is maybe a darker, all this stuff is unfortunate, but one of the big questions that we could also explore is what is the role of large earthquakes on the stability of features like the bluffs at Kalaloch. That's a question that's very hard to answer here, although there are templates for that around the world, and they're generally not good.
Okay, we've got two from our online audience. The first is, how much time does the Tree of Life have left? I've heard it's getting close to the ground.
That's a good question. And I also, in the line of being like Dr. Doom style person, I was called by a reporter from sfgate.com. It's a online newspaper. I don't know too much about it, but we had a long conversation about Kalaloch. I wish I'd sort of put a screenshot of the article up here because it was like, the article was sort of like, something about the tree life. And then below it was my quote, which was, "It's soon going to be driftwood."
Oh.
So it just seems to be the kind of things that come out of my mouth sometimes, but I don't. It's held on astonishingly long. I think that's incredible. But when is no longer there, it will not be a surprise to me.
Second question from our online audience, is the removal of the forest and related organisms associated with the forest connected to erosion?
Oh, yeah, so that's a good question. So, one of the things that probably plays, and I didn't point to this in sort of the talk, but certainly generally there's an association between site development and bluff erosion. That's probably occurring at Kalaloch to some degree. It doesn't explain sort of the broad scale of erosion that we see there. But certainly how you manage, especially water flow over a site, affects bluffs and affects erosion. It's an important thing to think about if you are managing a bluff top site or if you happen to live on a bluff top. I would certainly encourage you to think about that. And you see it play out at Kalaloch. There are seeps that are associated with stormwater drainage, for example, that clearly have eroded faster than the bluff around them. Now, again, I don't think that plays a role in sort of like the overall picture that we see here. That's just my hunch, but it definitely is a factor.
Okay, another tectonic question from online. Is there any measurable uplift associated with tectonic compression along the Pacific coast, and how may this affect the rate of erosion?
Oh, that's a great question, and also one that I didn't touch on. So there is a assumed relationship and modeled relationship between rising sea levels and accelerating bluff erosion, right? Just because we do expect that as sea levels rise, basically storm-driven processes, high tides and waves will just have more time at which they can eat away at the base of those bluffs. So certainly one of the things we could ask at a site like Kalaloch is sea level rise playing a role in what we're seeing now? And again, I think my conclusion is no, because we would expect to see it more broadly than we do, right near the creek. We do expect that sea level rise will be a stressor at that site in the future on the bluffs, and presumably maintain or accelerate bluff erosion. And it's actually not exactly clear whether sea level is already rising at Kalaloch or not. There's not a lot of measurements being made at that part of the coast. It does seem clear, and in fact, I'm gonna, at the risk of giving everyone a headache, I'm gonna go way back to that stratigraphic section that Glenn Thackeray drew, because I think it shows something kind of cool that I didn't bring up. Sorry about this. There's probably a faster way to do this, which some of you probably know, but I'm going with pressing the arrow. A lot of signs. I totally passed it. Okay, we're getting there. So what this section that Glenn Thackeray, oh my gosh, this is hard. Okay, here we go. So here's the section that Glenn Thackeray drew. Again, this kind of stratigraphic section. And what you can see in here is this dipping feature, right? It's kind of got this U shape to it. And that is associated with compression of the Olympic Peninsula. So basically the Olympic Peninsula is being very actively tectonically deformed. And is being sort of compressed to the northeast, if you will. And so, and this actually plays a role in how the land is moving vertically. So most of the coast is thought to be uplifting, fairly slow rates. We're talking as fast as your fingernail grows, 1 millimeter or 2 per year. There are no measurements from Kalaloch of whether the land is going up or down, and there's a lot of uncertainty. But this compression suggests the possibility that, at least at Kalaloch, there may be a little bit of maybe stability or subsidence. Because if you can imagine this landscape being compressed this way, this kind of part is being forced down by that compression force. Again, we don't have any measurements of this, so it's kind of inferred from modeling sometimes. But if that were the case, then that suggests that sea level rise is already playing out on the coast. Again, doesn't seem to be affecting the bluffs in any significant way yet, but may already be playing a role in some way, shape, or form on this section of coast.
Okay, thank you so much.
Can I add
Yes,
one thing? Okay, sorry. I should have brought this up before. I drew this thing on the board over here, and I wanted to get people's perspective, because this is a perspectives talk. This is your last chance for the year to give your perspective. And so basically, in stories like this, where we're managing the shoreline, managing erosion, there's fundamentally two options that you have. I've described the one that's been adopted at Kalaloch, which is retreat, right? That erosion influences something that we care about, and the response is to remove that thing. The other option that's most frequently used around the world is to try to hold that shoreline in position, right? To try to engineer something that enables you to keep that shoreline fixed in place and preserve whatever it is you're trying to protect so that you can keep it there. And one thing that I would love to get is your thoughts on along this continuum of defend versus retreat. Where should we be at a place like Kalaloch? So on your way out, there are two ways to do this. There are little stickies over there that you could throw up on that little timeline. You don't have to do this if you don't want, by the way, but you can do it. Throw a sticky up. If you have even some clever ideas, like this is what should happen, write those on the sticky, because I would love to see those. Or there's some dry erase markers and you can just put a little mark on the thing. But we'd love to get your take on your thoughts on where along that continuum we should be at a place like Kalaloch, because managing these problems is incredibly hard. You know, I talk about erosion kind of flippantly because I view it as like a scientific process, but it obviously has significant and heart-rending impacts, right? One thing that Amy Neal was talking about quite a bit when I talked to her on the phone was the number of people that have just expressed sadness about losing these places where important parts of their lives took place, whatever that may be. And so that's meaningful, right? So these are important questions about how we manage these kind of problems. So I'd encourage you to do that if you are willing, and thank you.
Thank you so much, Ian. The recording, like I said, will be online by the end of the week. Give us a couple of days and then you're welcome to share. And thank you all so much for coming. Check out the library's schedule of events for next month coming up.